Now, see a polarization of light by using a Nicol prism. So, Nicol prism is actually made by using the calcite crystals. It is cut in such a way, this angle is 68 degree, this is 68 degree, this is 90 degree. These crystals are joined with the help of here the glue, that is called Canada balsam, whose refractive index is 1.55. Now, this is unpolarized light here, which is falling on the calcite crystal. As this unpolarized light falls on the calcite crystal, it breaks into two parts. One is E ray, that is called extraordinary ray, another is called O ray, that is the ordinary ray. Now, calcite crystal has different refractive index for these two components of the light, that means for E ray and for the O ray, that is extraordinary and ordinary ray. So, refractive index of calcite crystals for O ray is 1.68 and for E ray is 1.486 and refractive index of Canada balsam is 1.55. Now, first look at the that is O ray. When this comes here, refractive index for this this one O ray is 1.68 and refractive index of Canada balsam is 1.5. It means O ray is actually going from denser to rarer medium. In that case, total internal reflection takes place and this component comes to this side. But see the E ray, calcite crystal is acting as a rarer medium as compared to the Canada balsam. So, for E ray there is actually incidence from rarer to denser. So, it gets deviated from its path, gets refracted and E ray is obtained over here. So, there we get the two components of these lights, E ray and O ray. By this way, this light has polarized because one vibration in one plane is this side, vibration is another plane in this side. So, we can polarize the light by using Nicol prism.